Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on irrotational and scalar potential, where we are going to find the value of ABC, that is the constant term, with respect to such that curl vector f should be equal to 0. What does curl vector f equal to 0 represent? Curl vector f represent the irrotational condition, and then we are going to find the scalar function phi such that it should satisfy vector f. Now let us simplify. First, let us find. We are going to find, or we need to find a comma b comma c such that curl vector f should be equal to 0. First, let us find curl vector f should be equal to 0, where curl vector f is given by determinant of I, j, k, दो बाई दो एक्स, दो बाई दो वाई, दो बाई दो जेड इंटू F1, F2, F3. What does F1, F2, F3 represent? Where the given vector field, that is vector F, which is equal to x plus y plus az I cap plus bx plus 2y minus z j cap plus x plus cy plus 2z k cap. Done. Where f1 represent x plus y plus az, where f2 represent bx plus 2y minus z, and f3 represent x plus cy plus 2z. Done. Yes. Now let us substitute in curl vector f. Curl vector f, which is equal to determinant of I, j, k divided, then we have the second row, दो by दो x, दो by दो y, दो by दो z. What is f1? We have x plus y plus az. f2 we have bx plus 2y minus z. f3 we have x plus cy plus 2z. Now do the determinant matrix multiplication, that is, let us represent there itself. Curl vector f, which is equal to, first, dou by dou y into this I cap, or I into dou by dou y into x plus cy plus 2z minus, now dou by dou z into this, dou by dou z into bx plus 2y minus z. Now minus j. First done. Now let us go with the minus j. Minus j into, that is dou by dou x into this, dou by dou x into x plus cy plus 2z minus this into this, that is dou by dou z into that is x plus y plus az. Correct? Yes. Now let us go with the k term, that is plus k into this first, that is dou by dou x into bx plus 2y minus z minus dou by dou y into x plus y plus az, x plus y plus a z. Done. Now let us differentiate each and every term with respect to given variable, that is curl vector f. Now I need to differentiate this whole term, but let us differentiate term by term. I into, first term we have x. X can be represented as x into 1, where x remains constant. Differentiation of 1 with respect to y is 0. 0 into x is 0. So any constant term other than variable, for example, if we don't have y term, this term becomes 0. Plus, Now we have c, yeah, we have y, c remains constant, differentiation of y, that is 1, plus 2z, in differentiation of 2z with respect to y is 0, minus, now I need to differentiate this whole term with respect to z. So what I'm going to do, bx, we don't have z, so this becomes 0, plus 2y, we don't have z, so this becomes 0, minus z, I can differentiate z with respect to z, that is minus 1. Done with respect to I? Yes. Similarly, let us go with respect to j. Minus j into, now differentiation of x with respect to x is 1, plus differentiation of cy with respect to x is 0, plus differentiation of 2z with respect to x is 0, minus, now differentiation of x with respect to z is 0, plus differentiation of y with respect to z is 0, plus differentiation of az with respect to z is, a remains constant, differentiation of z is 1. Now let us differentiate with respect to k, that is b remains constant, differentiation of x with respect to x is 1, plus 2y, differentiation with respect to x 0, minus z with respect to x 0, minus differentiation of x with respect to y 0, minus differentiation of y with respect to y 1, plus differentiation of az with respect to y 0. Now let us represent carefully, that is curl vector f, which is equal to I into c into 1 c plus 0 plus 0 c minus into 0 plus 0 0 0 minus 0 minus 1 into minus plus 1, it is c plus 1. Now minus j into 1 1 plus 0 plus 0 1, minus 0 plus 0 plus a into 1 a, that is minus a. Now plus k into b into 1 b. Now 0 minus 1 minus 1 minus 1 0 minus 1 minus into minus plus 1, minus into minus plus 1. Here also minus 1, this also minus 1. Then with respect to k, yes, curl vector f, which is equal to once again, okay, done. Now let us represent, since I need to represent the constant term c a b, so what we are going to consider, just we are going to consider this term, that is consider c plus 1 equal to 0, comma 1 minus a equal to 0, comma b plus 1 equal to 0, so that curl vector f should be equal to 0. So when c equal to minus 1 and a equal to 1, comma b equal to minus 1, if a b c equal to, if I simplify here, that is curl vector f, which is equal to I into minus 1 plus 1 minus j into 1 minus 1 plus k into minus 1 plus 1, get everything get cancelled, curl vector f equal to 0. If curl vector f equal to 0, then the given vector field is irrotational. If curl vector f is equal to 0, then the given vector field is irrotational. But the point, now we have find curl vector f equal to 0, but we need to find scalar function phi. How to find scalar function phi? Now let us see. To find scalar function phi, we are going to first represent the vector f, that is vector f, which is equal to x plus y plus az I cap plus bx plus 2y minus z j cap plus x plus cy plus 2z k cap, where vector f, which is equal to x plus y plus, what is the value of a? Now let us simplify. Put a equal to 1, b equal to -1. Okay, wait a second. Okay, see here, we have differentiation of y, that is, sorry, yes, since we have plus, we are going to get plus 0 plus, okay, this is minus, okay, this is also, sorry, this is also minus, you get plus, okay, sorry, you get minus 1 plus 1, get 0. Just please do recorrect it, okay. B is 1, B is 1, and C is also equal to -1. Yes, now if I simplify, vector f which is equal to x plus y plus 1 into z plus, what is b, 1 x plus 2y minus z j cap plus, what is x plus, what is c, -1, so minus into y minus y plus 2z k cap. Considering this, we are going to find the scalar function phi, that is, consider vector f which is equal to gradient phi, where gradient phi which is equal to dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap. Now substitute gradient phi which is equal to vector af. What is gradient phi? Dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap, which is equal to x plus y plus z I cap plus x plus 2y minus z j cap plus x minus y plus 2z k cap. Now separating this term with respect to variable x, that is direction I with direction I, j with respect to j, k with respect to k, that is, consider dou phi by dou x which is equal to x plus y plus z, comma, dou phi by dou y which is equal to x plus 2y minus z, comma, dou phi by dou z which is equal to x minus y plus 2z. Done. Considering this, we are going to find the scalar function phi. Just rewrite here, that is plus, okay, don't forget. Now consider dou phi by dou x which is equal to x plus y plus z. To find the scalar function phi, I am going to integrate with respect to x. Integrate with respect to x on both sides. What you get? Integral dou phi by dou x which is equal to integral x plus y plus z into dx. Since I am going to differentiate with respect to x, function that is f1 of y comma z, that is two variable y and z remains constant. Now integration and differentiation get cancelled, you get only the scalar function phi. Now integration of x with respect to dx, we have x square by 2 plus integration of y remains constant, integration of 1 with respect to dx, you have x. Similarly z, integration of z remains constant, integration of 1 with respect to dz, you get x plus f1 of y comma z, where phi which is equal to x square by 2 plus xy plus xz plus f1 of y comma z. This is the first scalar function. Similarly, repeat it for second scalar function, that is to find with respect to y. Consider what the second scalar function, dou phi by dou y which is equal to x plus 2y minus z. Integrate integrate with respect to y on both sides. You get integral of dou phi by dou y, which is equal to integral of x plus 2y minus z dy plus f2 of x comma z. Since I am integrating with respect to y, so x and z remains constant. Integration differentiation get cancelled, you get only the scalar function phi. Integration of x remains constant. Integration of 1 with respect to dy, you get y plus 2 into integration of y, you get y square by 2 minus z into integration of 1 with respect to dy is y. 2 get cancelled plus f2 of x comma z. You get phi, which is equal to xy plus y square minus yz plus f2 of x comma z. f2 of x comma z. This complete the second scalar function with respect to y. Similarly, let us do the third scalar function, that is considered with respect to z. Consider dou phi by dou z, which is equal to x minus y plus 2z. Integrate with respect to y on both sides. What do you get? Integral dou phi by dou z, which is equal to integral x minus y plus 2z dz. And since I am integrating with respect to z, so dz, but x and y remains constant, that is plus f3 of x comma y. Now integration differentiation get cancelled, just to get the function phi. Now x remains constant, 1 with respect to integration dz, you get z, minus y into 1 integration of dz, you get z, plus 2 into integration of z, you get z square by 2 plus f3 of x comma y. 2 get cancelled, phi, which is equal to xz minus yz plus z square plus f3 of x comma y. Now considering this as equation 1, 2 and 3, we are going to give this function, that is f1 of y comma z, f2 of x comma z and f3 of x comma y, so that it should satisfy all the three scalar function phi. That is, first let us represent f1 of y comma z, which is equal to, next f2 of x comma z, which is equal to f3 of x comma y, which is equal to, so that it should satisfy the scalar function phi. First let us look into the all the three equation, then we represent. In the first equation we have x square by 2, but here we don't have x square by 2, so I am going to give here x square by 2. But in the third equation also we don't have, so x square by 2 I am going to give. Okay, done. Now we have xy, here also we have xy, but here we don't have xy, so plus xy, where in f3. Got the point? Now let us go with the first, that is xz. We have xz, we don't have xz in equation number 2, so what we are going to give? Xz in equation number 2. But here we have xz, here see we have xz satisfied, then no need of giving in f3. Next let us go with, now let us see here we have xy, here also we have xy, here in the f3 we don't have xy, but here we have given xy, so it's satisfied. Now y square, here we don't have y square, that is in first equation y square. In the last equation also we don't have y square, so plus y square. Done. Now minus yz, here we don't have minus yz, so we are giving minus yz. But in equation number 3 we have minus yz. Done. Now let us satisfy this. Xz, we have xz, we don't have xz, but we have given xz already, no need of giving another time. Now we have minus yz, we don't have minus yz, but we have given minus yz, no need. Here we have minus yz, satisfied. Next we have z square, we don't have z square here, and we don't have z square in f2, that is plus z square plus z square plus z square. so that it satisfies all the equation. Now let us compare with respect to first, that is x square by 2 plus xy plus xz plus y square minus yz plus z square. Just let us rearrange the term, that is phi, which is equal to x square by 2 plus y square plus z square plus xy plus xz minus yz. This is the our required scalar function phi for the given what vector field f. This is how, for whether the given scalar function is correct or wrong, just differentiate with respect to x, so that you need to get the vector field, that is this one. That is, just differentiate vector f, which is equal to let us differentiate with respect to x, that is dou phi by dou x, so that difference 1 by 2 remains constant. Differentiation of x square, you get 2x plus we don't have x, so this becomes 0. We don't have x here, so this term also becomes 0. We have x, differentiation of x is 1 into y, plus differentiation of x is 1 into z, minus 0. See, 2 get cancelled, x plus y plus z. You get the first scalar function. If one condition is satisfied, all the equation, that is with respect to j and k, also will satisfy. This is just a verification. It is just a verification, so that whether the scalar function is correct or wrong. I hope you have understood this problem, how to solve and how to represent. First we are going to find curl vector f. Considering that curl vector f, in that we are going to find vector f, which is equal to, with respect to ABC constant term, and simplifying you get vector f. Considering this and gradient phi, we are going to find the scalar function phi, so that it satisfies the again vector f. This is how we are going to represent this irrotational and scalar potential, which is the one of the most important question in the VTU main examination. For more videos, please do like, share and subscribe. See you in the next video. Thank you.